Again, welcome to numerical series of electronics device. And today our numerical problem is design a NPN common emitter self bias circuit to satisfy the following condition. That is IC equal to 2 milliampere, BC equal to 8 volt. Assume that BCC equal to 16 volt and beta equal to 100. You have to we have to design NPN common emitter to satisfy all these conditions. Solution: the common emitter, C common emitter common self bias circuit is shown below. Let the voltage drop across RE is 20% of VCC. That is RE equal to VRE equal to 20% of 16, that is 20 upon 100 into 16, that is 3.2 volt, and VRE equal to IERE, but IERE equal to 3.2. We have already found that RE equal to 3.2 upon 2 into 10 to the power minus 3. The value of I is 2 milliampere already given, so 2 into 10 to the power minus 3, that is 1.6 kilo ohm, and IC is nearly equal to IE. And this is a figure of self bias or voltage divider circuit. This is R1 and this is R2, RC and RE, and here voltage current through R1 is IR1, R2 is IR2. Similarly, RC is IC and RE is IE, and this is the base current, and this is VCC. With KVL in the output loop, we get VCC equal to IC power VCE plus IERE. Then put all this value, we can get the value of RC, and the value of RC is 2.4 kilo ohm. Assume IRE greater than or equal to 10 IB, but IRE equal to IR2 plus IB, and let IR1, this is IR1 not IR2, IR1 equal to 10 IB from here. Then IR2 equal to IR1 minus IB, that is 10 IB minus IB, 9 IB, and IR2 equal to 2 into IC upon beta. In the place of IB we can write IC upon beta, that is 9 into 2 into 10 to the power minus 3 upon 100, that is 180 microampere. But VR2 equal to IR2 into R2, and VR2 equal to VB plus IERE. Then put the value of VB and IERE, we can get 3.9 volt. Then IR2 equal to 3.9 upon 180 micro ampere, that is 2.16 kilo ohm. Now IR1 equal to 10 into 2 into 10 to the power minus 3 upon 100, that is 200 microampere. Again IR1 equal to VCC minus VIR2 BR2 upon R1, then R1 equal to 16 minus 3.9 upon 2 into 200 into 10 to the power minus 6, that is 6.05 kilo